Spark and PySpark are not universal programming solutions. They sound like they might be. I mean, when I describe them, dividing up a task, working on it, working on the pieces simultaneously, doing lazy evaluation, all that stuff sounds like it might be applicable to, virtually any problem. But I think this is probably a pretty universal programming experience. So maybe we can all relate the idea that we're writing a program and we need to do something, unusual or something that we haven't done before. And we create a messy little hack to do it. And then we see a messy little hack, but then we say, no, I'm going to do this the right way, whatever the right way means, whether it's using a fancy new library or looping through stuff instead of making a few manual changes. And by the time you've finished doing stuff the right way, you've spent hours more on it than you would have if you'd gone with your messy little hack. And and Spark in general is like that. Spark has significant overhead. It has significant startup cost. And because of that, it's only usable or only appropriate, I guess I should say, in cases where your data is relatively large. Just for instructional purposes, we're going to use it frequently in this class, even when the data set is small. But I do want to demonstrate this. So, in an earlier video, I suggested that computing averages was something that we could do very naturally with distributed computing. So let's compute some averages. Here we are in boring old NumPy. I'm going to compute the average of the first 200 numbers. The first 200 integers starting from 0, and I'm going to calculate how long it takes me. And NumPy is blisteringly fast at this, 0.0001 seconds. And now I'll do the same thing in Spark. So here we are, our fancy new tool, and I'll hit the run button. And Spark is not blisteringly fast, as you can see. This is taking orders of magnitude longer than it did with NumPy. In fact, I didn't end up pausing it, but I mean, it took me 22 seconds to compute the average of 200 numbers. So that is shameful. But again, this isn't what Spark is for. It's not what PySpark is for. This Spark and PySpark are for big numbers. So let's go from 200 to 200 million. And this time I really am going to pause the recording. It's going to take a little while. I'll run that file, or I guess it didn't take very long at all. It took about 0.8 seconds. My error. Let's try the same thing in Spark. And here we are. It took 0.47 seconds. It's a little hard for me. Let me try 200 again. Okay, so I talked about startup cost. The reason that 200 took so fast originally was that we had intense, startup cost. Now that Spark started, we have zero point 0.3 seconds. That's a more normal number. That's more like I was expecting. Anyway, back to 200 million. About the same, as a matter of fact. 0.33 seconds. So you see, Spark is scaling up really well. Um, 200, about zero point 0.3 seconds. 200 million, about zero point 0.3, zero point 0.4 seconds. And again, compare that to NumPy. 0.0001 seconds. 0.7 seconds. So Spark is about as fast doing this problem with 200 observations as it is with 200 million observations. Whereas NumPy starts faster, but does not scale nearly as well. And if we increase these numbers still further, so now we're going to start to chug a little. But let's look at 200 billion seconds in Spark. Tum, our distribution. This time I really did pause it, about 36 seconds. So a massive number, but we can deal with it in a normal amount of time. We're not leaving our computer on overnight. Let's see what happens here when I try to do this. I'll click that button and I will get an error saying that the data set I am trying to create is too big to store on my computer. I do not have 1.46 terabytes available. So once we got to 200 billion, we really see the difference. My local machine just completely failed, whereas PySpark and Spark were able to not only deal with this, but deal with this relatively quickly. And I mean, you can say, I guess you could say, well, what if I just got more RAM? What if I got a bigger laptop? And it's like, okay, I can get a bigger laptop. What happens when I want to do that? Do I get a second, even bigger laptop? Once you start getting into numbers like this, you need specialized tools. You need things like Spark and Databricks. So, having said that, we are not in this class going to get lost in the weeds of, looking at these data sets and trying to decide, do I need Spark? Do I not need Spark? We are going to treat the data sets we use as if they are big data, even if more traditional methods would work or would even work better. So I don't want you to, obsess. Do I need to use Spark? Do I not need to use Spark? I just need you to realize that Spark is not the solution to everything. Spark works well in specific situations where we have very big data sets. It is not the cure all of Python programming woes.